Thank you. Thank you. That was actually quite a mouthful to say, like my name, Zeam, all this stuff. So good job. Um, yeah, hi. Um, so I assume a lot of you have heard that zkVMs are the future. We hear a lot of nice promises. It's all gonna be sunshine and rainbows, and I also think that. Um, but I still wanted to figure out, what is the real status of all those things. So I was looking for an opportunity to look into these ZKVMs and try to build a program. And then a couple months back, Gajinder, who unfortunately could not be here today, wanted to start a project with the Beam chain, and Beam chain contains a lot of zkVM, so that was my chance to have a closer look, and hopefully I'll share some of that today. Very quick summary. What is the Beam chain? I mean, I assume most of you already know, but it's a reboot of the Beacon chain in a way. We want to fix all things that we thought were a good idea back then, but turned out to not live up to expectations. And we want to throw in more stuff, quantum resistance, faster finality, shorter slots, all those things. It will be perfect this time. And I'm going to make a very summarized version of what a Beam client does. If you look at the top top left corner, you see things that a regular client today would do today. It has a state, it has a block that it generated or got from the network, and it's going to run it. So this is where things start changing a bit. It needs to execute a transition function to figure out if the execution is correct. But in zkVMs, we do that a bit differently. We don't actually execute the block. Instead, we pass it through a some like tower of components that I will describe later. And what comes of this group of components is a proof, and also potentially a state diff that you can use to circle back and update the state with, so that you can be ready for the next block. Very sketchy, but yeah, that's the gist. And so what happens with this proof and this block that you've got, or it could also be a commitment to the block, but for simplification, I will say this is the block. You send it over to the network, and any other client that receives this block and this proof can just run the verification algorithm, so they don't actually need to run the block. They don't need to check every transaction, and then they accept the block or not. Of course, as such, it's enough for a testing. You can validate that you can sign that the block is correct, but you might want to do more things. So you might also want to recover the state diff. Like there's a bit of a circuit here. It's a bit hard to read, but the idea is that once you have proven the diffs, you can also attach them, pass them over the network, and update the states of whoever verifies, which might be another client that will want to create a block further down the road and potentially prove it. Right, so that's the general idea. We have Zeam, which is a Beam client written in Zig. So it was a project started by me and Gajinder. Gajinder, formerly Ethereum.js, now full-time on Zeam. And I'm gonna start with preempting the most obvious question: why Zig? Zig is a language that is easy to learn, that is more importantly very easy to read, so much easier to maintain. There's only one way to do things. It's a language that plays very well with others, meaning if you want to integrate a C library or all those things, you do not want to have like something that Rust forces you to do. And I'm sorry for all the Rusticians. I'm sure we'll discuss that after the talk. But you don't need to make basically a copy of the C program in your Rust program. Zig integrates directly, so it's very useful. And yeah, like when in terms of safety, yes, Rust is very memory safe, but Zig is not too bad either. It will detect a lot of the issues, and it's also not getting in your way for that. So it flow, like writing programs is flowing. It's very nice, and yeah, there's a couple more things. For example, this is the this is the screenshot I shared. They decided also to get rid of LLVM in the long run, but currently you have both, like a custom backend and LLVM. So according to that specific issue, they say LLVM is buggy on a lot of targets. So I doubt that rewriting your own backend from scratch will not yield the same kind of problems, but at least you have a way to work around some bugs. And yeah, the last thing that is very nice is that which is also a feature of Rust, everything is self-contained, so you don't need an external libc, which saves a lot of headaches when you're cross-compiling to a different architecture. All right, let's get to the architecture of the guest program per se. So what I call the guest program is the business logic, i.e. the state transition function. And for this to work, you need like the environment of the zkVM, at least currently, is more often than not very much like an embedded target. So there's nothing available. There's no memory allocator. There's none of the nice features that we expect from an OS. So you need some component called a runtime that will link to it, and that will allow the state transition function to run on top of the zkVM. Yeah, one point I forgot to add is that this when I talk about this being an embedded target, some zkVMs are actually trying to implement the full Linux system call interface. So that means you could take a regular Linux binary and put it in your zkVM, and if that works, that's going to solve a lot of headaches. So okay, currently, or at least the way I did it, I had like 3 options: either stick with Rust for the runtime and the STF. This is basically what every zkVM provides you as their starter toolkit, as their SDK. You can also try to do the STF in Zig and somehow get the Rust runtime compiled as a library and link against it. First, it's not always available. You need to tinker a bit, do some cargo magic, and yeah, you're still a tributary of cargo, which I didn't really want to have because Zig has its own build system. So the approach that I chose was to rewrite the runtime in Zig as well, which was quite challenging, but also quite interesting because I found a lot of bugs in a lot of zkVMs. Yeah, so I'll call that runtime diversity. What's in runtime? You have, okay, so assuming this is an embedded target, you have basically what you have to do for an operating system. You need to set up the heap, you need to set up the stack, you need to potentially initialize more things, although most of the time you don't. And then you need to provide some functions that represent system calls, so reading a file or the equivalent of that, telling the zkVM that the program has finished executing, things like this. So, like I said, ReZero, for example, they have a full-fledged Linux system call interface, so you don't really need to do this. You actually have a kernel and a program. So what you prove is across the kernel, the system call boundary. That's quite nice. But others are more bare bones. But yeah, pretty much the only thing that they have in common is that if you step out of the well-trodden path, you're going to find trouble. Right. So one precision I wanted to say is that I kind of interchangeably use system calls and precompiles. They are not the same thing, but it's kind of confusing because in most zkVMs, the system precompiles are actually implemented as system calls. So what we should, or at least what I should have said, is system calls are everything that you can think of Unix would do. read input data, provide you a function to leave the zkVM, things like this. Excuse me. And precompiles are really how we think of them in the EVM space. So some computation that you get out of the normal flow of execution that the prover will will make happen for you and hopefully prove much faster. Right. So, okay, regarding the zeam guest program, we have to build like one executable per zkVM. So this is an example of the build system. There's a bit of Rust building at the beginning. I'll explain afterwards what this is. But you can see that I'm building the ReZero executable and the Powder executable. Yeah, there were actually a bit more. But it goes so fast that you really have to I wasn't fast enough with the screenshot. So the structure, I forgot to put a legend, by the way. So everything in yellow is written in Zig, and everything in orange is written in Rust. So you have the classic client code, everything that has to do networking, things like this. And then when you need to prove a block, excuse me, you have to go through a Rust interface. So because the zkVM itself is written in Rust and the verification function is written in Rust as well. So yeah, it makes for a bit of a mash of languages together. Some of them have to be built as libraries to be imported in the other system. But ultimately, it works. And you can see an execution. So if you look at the start, I hope it's readable. You can see that it starts with the glue code being built, and then I have some debug traces. But if you look at the last two blocks of text, this represents the execution and proving of two like consensus layer blocks. So you can see state transition running blocks, transition function, state transition completed, and the proof size. So yeah, that's pretty much it. How far did I go? Well, obviously, if you haven't gotten the message just yet, it's quite complex and intricate, and every zkVM has its own specificity. So with ReZero, I managed to go through the whole cycle, which is why you can see. Like the previous screen was actually a run with ReZero. I also did it with Powder. I got the runtime to work. I got the prover to work. The verifier had some issues, but Powder decided to drop the RIS5 VM. So I guess it was a learning experience. Let's put it this way. And then I started working on Sino, SP1, and Zisk to various degrees. I would say Sino is a bit up and coming, so this one is not actively developed right now. But yeah, I expect to have SP1 and Zisk pretty soon. Excuse me. So yeah, I think if I learned anything from this experience, is that it would be great to have a standard. So there is, in fact, an effort at the EF to try to make this happen. But the idea is that if someone has to write a runtime for every single zkVM, it's a lot of duplicated work. It's not particularly interesting in terms of business value, and more importantly, the glue code is the annoying part, because I was lucky so far. All the zkVMs I use the same version of the compiler, but Rust versions tend to be incompatible. So the day this happens, it's going to be a maintenance nightmare. So there are two ways out of this. Either every zkVM provides a C runtime that Zig could use, or maybe Go or whatever, or the alternative is the standardization. Try to simply make the zkVM behave as much as possible like Linux, and then also agree on a set of precompiles. And when when this happens, all I have to do is build only one executable that can run on every zkVM, and this way it would really greatly simplify basically everything, the tooling, the development time, everything. The last thing is from the conversation I had last week, this week. I think it's a bit too early to standardize on the architecture, but at least as long as the program structure works, it should be fine. Yep, that's pretty much it. Okay. Okay. Oh wow. When Zeam Beam MVP? Well, we need a spec for that. The spec is still it should be released at the end of this month, so we're hoping for that. So we're targeting at the end of the year, hopefully. Don't quote me on this, but that's our personal target. What does Zig compile to? Everything, pretty much everything. Was there if there are several targets, which zkVMs did you use? So yeah, I forgot to say that, but it was in the slides. We used we used all the RIS5 zkVM targets I could lay my hands on. But yeah, we would like to look into MIPS. Zig will totally be able to cross compile to MIPS, and if there's WASM, that's also an option. Which zkVM was the easiest to develop for? Ooh, that's I mean, excuse me, that's pretty obvious. Oh, right, you don't have the slides anymore. That's pretty obvious. It's RIS5. RIS0. They have the tooling. It's really nice. How was the transition from Go to Zig? Pretty nice. Pretty nice. Yeah, I think Zig is a great language. Go is a great language too. So. Okay, I know what that means. Don't force me to choose a camp. Would you rather be called William, as people can pronounce Guillaume properly outside of France and Quebec? I don't know if they can really pronounce it properly in Quebec. Sure, whatever floats your boat. Have you used OpenVM? No, that's on my list. Yes. Oh, sorry, I missed one. You said you found bugs in zkVM plural, which oh, that's embarrassing. I found some in Sino. I found some in Powder. And when I say bug, it doesn't mean like the prover is broken. It's just I run a program and it fails, and it's not my fault. Yeah, SP1 I started, but okay, SP1 I'm less sure because that's probably my fault. What is your beef with Rust? I'm just I don't have a beef with Rust. I'm just a non-practitioner. Have you? No, okay. This one was already covered. The runtime could be reused for different guest programs, right? Wait, I'm not sure I understand the question, but yeah, the right. Okay, now I do. Yes, absolutely. Once the runtime is written, you should be able to reuse it in every Zig C program that you want. How much of the Zeam client is implemented? I mean, given the fact there's no spec, I would say all of it. But yes, probably going to change in the next month. But so, okay, just to maybe give more information on this, we have the zkVM part, we have the proving manager. We have we're waiting for a Zig lip2p implementation, but I think we can build a prototype. Like we'll be able to build a prototype before the end of the year for sure, and I'm hoping before the end of the summer. Summer 2025. That's it. Oh, really? I'm not, but thank you. Is there a beacon chain-like client in Zig? If not, build it, please. Okay, sure.